Welcome to the Explainer. Okay, let's dive right into this, because today we're exploring a genuinely fascinating question. How do we actually see the unseeable? Seriously, how do we map out the entire universe or something as microscopic as a strand of DNA in a way that our human brains can actually wrap around? Well, that is exactly what we're going to figure out as we explore the concept of visual science.
To start things off, I want you to take just a quick second and reflect on your own media consumption. When I say the word science, what does it actually look like in your mind's eye? Do you immediately picture gritty, raw footage of a massive space shuttle launch, or maybe a grainy black and white video from some historic university lecture? Or, depending on what you've been watching lately, does your brain jump to a highly polished stock model in a crisp white coat holding a glowing blue beaker in a dramatically lit laboratory? You see, our understanding of the world is deeply, deeply influenced by how it's visually packaged for us.
To unpack all of this, we're going to follow a four-part journey today. First, the curated cosmos, then Earth, mind, and biology, followed by the stock science aesthetic, and finally, inspiring the next generation.
All right, starting with part one, the curated cosmos, gritty reality and historic discoveries.
If you really want to see the absolute pinnacle of this, you've got to check out Open Culture. They meticulously scoured the web and curated exactly 125 great science videos to capture the very essence of our universe. They gathered everything from theoretical physicist Lawrence Krauss explaining how the universe literally came from nothing, to Neil deGrasse Tyson breaking down what our demise would actually look like in Death by Black Hole. It is just this incredible visual archive of human curiosity. And right in that collection, there's a clip this source material literally calls one of the coolest movies in all of science. No joke, it is actual footage showing stars orbiting around a supermassive black hole right at the center of our galaxy. But here is the real kicker. That footage was captured over the past 15 Earth years. Just think about that. Through the sheer power of visual media, we can sit back and watch a decade and a half of massive cosmic movement happen right before our very eyes. Let's move to a timeline and see how this builds across history. Back in 1952, we had A is for Atom, which was this animated public relations film produced by General Electric to try and sway public opinion on nuclear energy. Then jump forward to 1964, and we get the pure, unadulterated academic genius of the Richard Feynman Cornell lectures, just posted online for anyone to watch. And then, wow, 1969, landing on the moon, the raw broadcast. As the source material asks, does watching that ever get old? Definitely not. This timeline totally shows our journey from animated PR into the classroom, straight to the gritty reality of walking on another world. Moving right along to section 2, Earth, Mind, and Biology, looking inward. Because visual science isn't just outer space, right? The sheer breadth of scientific topics we consume visually is absolutely staggering. I mean, we can watch a really fun clip explaining the basic physics behind a quarterback's pass. We can watch theoretical physicist Brian Greene take us into the wild, speculative world of hidden dimensions. We can watch unbelievable footage produced by the Georgia Institute of Technology showing fire ants creating a life raft in 100 seconds flat. Or we can even watch the Dalai Lama sitting down at Stanford to discuss the neurobiological underpinnings of compassion. Visual science is everything around us and everything inside us. But sometimes the most impactful visuals are the ones that just perfectly capture the human spirit. The Open Culture collection highlights this one video of Stephen Hawking entering a state of weightlessness on the famous vomit comet. It completely grounds our entire conversation today. It's such an evocative anecdote that shows exactly what pure genius looks like floating at zero gravity. It's science for sure, but it is deeply, wonderfully human. And this brilliantly illustrates a major divide in how we actually consume information today. On one side, we have real scientific footage. The grainy, the real, the raw stuff, like NASA's Solar Dynamics Observatory capturing giant solar storms in high def, or literal cells moving around under a microscope. But then, on the exact opposite side, we have commercial scientific footage, the hyper-polished, pristine, rendered laboratories. Which brings us perfectly to section 3, the stock science aesthetic, representational and commercial. 1,424,200. That is the staggering number of science stock videos and royalty-free footage clips available right now on just one platform, iStock. Nearly 1.5 million clips. We are talking about everything here, from time-lapses of seed germination complete with perfect, warm sun flares, to embryologists performing IVF, to actors just enthusiastically pointing at glowing data screens. It completely shows the massive, massive scale of commercial science media. So, why on earth does this massive library even exist? Well, it all boils down to the concept of visual metaphor. Because here's the reality check: we simply cannot film big data. You can't just point a camera at artificial intelligence or an algorithm and say, action. So, we are forced to invent these visual symbols. Those stock libraries are absolutely filled to the brim with intricate connection lines, glowing digital nodes, and seamless loops of digital analytics, all trying to represent abstract data that just cannot be traditionally filmed. Now, what's really interesting here is how these visual metaphors have totally evolved into strict visual tropes. I mean, think about it. When you watch a tech presentation, you see these exact things over and over. The endlessly rotating 3D glowing DNA loops on a deep blue background. The dynamic AI data flow spheres made out of all those interconnected cubes. Really attractive scientists intensely using micropipettes to mix liquids in test tubes. And seriously, notice the lighting next time you see one. These stock scientists are almost always conducting research in incredibly dark labs with cold blue color grading. Oh, and of course, futuristic holograms of human skeletons with glowing red spots highlighting injuries. It's this highly curated aesthetic, completely designed to instantly scream innovation. But let's contrast those commercial stock metaphors with how high-level educational media bends reality to actually help us learn. Instead of just creating a glowing blue graphic to sell a piece of software, educational visual science bends time itself to make the unseeable completely visible. Like this mind-blowing example from the Open Culture list, compressing 12 billion years of a star's life cycle into just a 6-minute video. That is visual science at its absolute best right there. It takes the totally incomprehensible scale of the universe and fits it perfectly into a regular human attention span.
Okay, time for our final part, Section 4, Inspiring the Next Generation, the Future and Accessible.
Major scientific organizations know for a fact that they have to compete in this crazy, highly visual world if they want to inspire the next wave of engineers and astronauts. NASA, for instance, isn't just relying on dusty old textbook photos anymore. They're deploying seriously modern, accessible tools to engage youth in STEM. They've got the NASA Kids Club, they utilize all this interactive STEM multimedia, they've even launched NASA Plus apps with dedicated video series, and they offer virtual guest programs for upcoming launches and landings. They are literally taking the gritty reality of space and the sleekness of modern interfaces and putting it right into the hands of kids today.
Which brings us to the very end of our explainer. I want to leave you with a really provocative question to think about. How will the next generation visualize the cosmos? I mean, we've gone from 1950s animated PR films to 15-year actual time lapses of black holes to millions of glowing AI stock video metaphors to interactive apps. As technology continues to evolve, is the line between actual footage and digital representation just going to blur completely? It is a fascinating thought to take with you. Thank you so much for joining me today, and I really hope this journey helped you see science in a whole new light.